When I first introduced the whole idea of a derivative, I mentioned also the idea of a higher derivative, which you have seen in high school as well. So this one is basically just a little bit of a review, recap, and clarification of a couple of things having to do with higher derivatives, together with an opportunity for us to practice on it. So, just to remind you, what do we mean here by higher derivatives? Well, we started by defining f prime as the notation for the derivative of a function f of x. So we call this one also the first derivative. And as you remember, the whole point of computing this thing was to figure out what the slope of a curve was at a certain point. Well, at this point, once we compute f prime, well, f prime is itself a function. So what we can do is we can take its derivative, and so we indicate that by f double prime, and that will be the derivative of f prime, and of course we call that the second derivative. And as we're going to see later, this second derivative actually graphically corresponds to the concavity, or gives us information about the concavity of a function. Again, this is stuff you have seen in high school, but we're going to analyze a little bit more and use a little bit more consistently later on in the course. And at this point, there is no reason for stopping. We can compute the third derivative, which would be the derivative of the second derivative. And some of you may know that the third derivative graphically, and sometimes even in an applied situation, describes what is generally called the jerk. Again, we're going to look at what that means later on. Once again, I'm not calling you a jerk. What I'm saying is that the third derivative represents the jerk. Now, notice a little bit about the notation once we get into even higher derivatives. Of course, there is no point or no reason for stopping at 3. So what we can do is we can define generally the nth derivative of a function as being the derivative of the n minus 1 derivative. So we can keep going with this game as long as we want, but as long as the function allows us to. Now notice one little thing about the notation, and that is that we denote the nth derivative not by a whole bunch of primes, which would be very difficult to count, but by the order of the derivative, that will be the number n, in brackets in the exponent position. Now this makes things even more complicated, remembering that when we put just a regular number, that means a power. If we put a negative 1, that means an inverse, and now if we put the same number but in brackets, that means derivative. Unfortunately, that is the notation that everybody uses, and so you need to get used to it and make sure that you don't get confused either in using the notation or interpreting the notation as you go. Now, what are we going to do with higher derivatives? Well, as I just mentioned, first and second derivative, and occasionally third derivative, but probably not very much or not at all, are used in graphing a function. Okay, but what about the other ones? Well, here is a little drill that we can do, and I'll explain in a minute why we may want to do this drill. And it is to develop a formula for the nth derivative of a function. Now, how does that work? So let's say I give you a function and I ask you to compute a formula for the nth derivative. How can you come up with that? Well, here is the method. Well, first of all, what you want to do is compute the first 4 to 7 derivatives. Now, why am I saying 4 to 7? Those are basically rules of thumb. What I'm saying is that you cannot get, or it's very, very difficult and very rare to be able to obtain the formula for the nth derivative for a general n, but just computing the first 2 or 3. So you may want to start at 4, and sometimes you may need to compute a few more, and usually in exercises you will never have to go beyond the 7th. Actually, it's unlikely you're going to have to go beyond the 4th. But occasionally you may want to take more derivatives in order to figure out what's going on. After you have written down those derivatives, oh, and by the way, this is very important, as you compute those derivatives, do not simplify things, do not multiply things together and so on. As the derivative is computed, as the formula gets computed, leave it as is. And the reason for that is because in that way, most of the times the pattern becomes more apparent rather than if you multiply things together and simplify. So keep things as they are. Another reason for not simplifying, resisting the temptation to simplify. Now, after you've done that, look at the pattern that you've obtained. So put all those 4 to 7 derivatives under your eyes on the same page and see what kind of pattern you are observing. Now, sometimes it's possible that the pattern is not visible at all, but again, by using and following the fundamental theorem of cooked up exercises, that's not going to happen in questions that we're going to give you for tests. In those questions, there will be a fairly clearly visible pattern. Okay, and so if possible, what you're going to do is you're going to generalize that pattern and obtain therefore a general formula. I'm going to give you one example in a few seconds, and we're going to do some more in class. However, the one thing that I would like you to do is at this stage what we're doing is we're just getting acquainted with these higher derivatives. So even though your textbook and other textbooks may in fact come up with some really elegant formula for the general pattern of the nth derivative, don't get hung up on notation. If you cannot figure out the precise technical beautiful mathematical notation for it, just indicate what you think the pattern is the best way you can. Just always use proper notation, but don't look always for the most elegant formulation of it. Now, how do we use these things? Well, for now, we're going to use these kinds of exercises just for practice to compute more and more derivatives and to start with the exercise of recognizing patterns, which is an important aspect of mathematical research and mathematical practice. However, later on, in fact, in the second term, we're going to see that these higher derivatives will have applications in finding out information and properties of functions. So just hold on to your head for now, just practice as mental calisthenics, but later on we will have a look at these things for further applications.